Welcome to day 2 of the NeuroHackademy. We're going to get started off with Russ Poldrack back for a talk on AI-assisted programming in just a second, but I have just a few quick announcements first. So a few things about today. During most of today, you're going to have choices about what you go to. We're going to post some information about the choices as we go through the day. I already posted a little bit about the Python choice this morning, but just to review, we're going to have Introduction to Python in Alder 103 over here. That'll be for anyone who's new to Python or wants a review on the basic language concepts. That's in Alder 103. We'll have Scientific Python here in the auditorium. That'll be with me, and it'll be basically NumPy and Pandas, and if we have extra time, SciPy and some of that kind of stuff. And then finally, Ariel will be in Alder 106. Talking about the design and implementation of Python libraries. Now the schedule says Alder 107, but Alder 107 is locked for some reason today, so we're going to do it in 106. We'll post this online too. So everyone who's joining us remotely, please go to Alder 106 instead of 107 for that if you're going to that particular talk. Additionally, at the end of today, we're going to have an optional campus tour. I'm just going to lead you. It's not anything official. But we'll meet out here in the Alder Commons right after the last session at 5 o'clock, and we'll do a quick, probably 20-minute tour of campus, and anyone who is welcome to come along. I think that's all the announcements for this morning. So with that, I'll go ahead and hand it over to Russ.
All right, thanks. Good morning, everybody. So I think that it will probably be useful for you to be able to look at my slides on your own device. So you can use this QR code. The link is also in the in Slack. Just because there's going to be some slides that have like some kind of small text on them that might be, especially if you're in the back of the room, might be a little hard to see. I'll kind of talk through them, so it's not essential, but I think it could be useful. I want to start actually with a little audience response. If you go, there's a QR code here, or if you go to polev.com/Russ Poldrack. The question is, why do we need code? And you're going to spend a bunch of time learning about how to write code. So this is one of those things where you can type in, your answers and then upvote and downvote other answers once they get typed in. So we'll give you a couple minutes to.
What was the link again?
Oh, it's it's up at the top, polev.com/Russ Poldrack. Add your answers and go on and upvote whatever you think is a good answer. Okay, so it seems like we kind of have 3 winners here: to process large amounts of data efficiently, automate processes, and to communicate with the machine, since computers don't speak human language. It's the third one that I'm going to focus on this morning, because that is, I think, ultimately the reason why we have code. Code is a way for us to talk to computers to tell them what to do for us. And when you think about code this way, this is how we, I think, can come to think about the role that AI is going to play in, helping us to write code. Perfect. So coding started out not with people writing, things on with typewriters. It actually started out with punching holes in cards. My mom actually was involved in computerizing a bank in the 1960s. So this is the way that the computers worked then. Punch cards. Okay, so that was the first step in the evolution of coding. When I started programming in the 1980s, I didn't program in this language, which is called assembly language, but this is how some people program, which is actually giving,
in directions to the chip about like how to move things between different places in memory, like really low level sort of stuff, right? Not so to write the, there's this famous thing that people often write when they're first programming, the hello world program, basically to say something, to tell the computer to print out hello world. This is how you would do hello world in assembly language for an IBM PC. Not exactly trivial. This is how you do it in Python, a little easier. And now we don't need to like know the language itself, right? If there's a new language like Rust and I want to know how do I make a hello world program, I can just go to ChatGPT and say, write a hello world program in Rust. And it will do that. I assume that this runs. I didn't actually try it. And this has led some people to say, the hottest new, Karpathy's a big like, AI person. The hottest new programming language is English. He said this a couple of years ago, actually, when GPT-4 first came out. Now we have tools that go even farther, right? Where this is Claude Code. This is me telling Claude Code to write a hello world program in Python, and it's going to go do some thinking for a moment, and it's going to ultimately, it's going to ask me, do you want me to make this file? Yes. It's going to go create the file, and now I can go run the file to make it work if I want. This is this thing we call Claude Code. I'll spend some time later today talking about Claude Code. We want the next slide. So you may have heard of this concept vibe coding. How many of you have heard of vibe coding? So vibe coding is this idea of basically writing code when you have absolutely no idea what you're doing, just using AI. Some people think it actually works. It actually does work sometimes. I'll show you examples. But this has led people, if you go on YouTube, there's no shortage of videos about how coding is dead. I don't think coding's dead, but coding is changing for sure. The important point I want to make, it gets back to the point that came up in the poll, is that programming or software engineering is not the same thing as coding, right? Coding is writing something down in a specific programming language like Python or Rust or C++ or whatever. Programming is figuring out how to take a problem that's a human problem and turn it into a way for the computer to do the thing. So this is Bob Martin, who wrote this book called Clean Code, a really good book on kind of building good software, doing good software engineering. He says, some have suggested that we're close to the end of code. He wrote this in 2009, right, way before AI, that soon all code will be generated instead of written. Programmers simply won't be needed because business people will generate programs with specifications. Nonsense. We'll never be rid of code because code represents the details of the requirements. At some level, those details cannot be ignored or abstracted. They have to be specified. And specifying requirements in such detail that a machine can execute them is programming, regardless of what language you're doing it in. So my wife's an interior designer, and we've renovated a number of houses. So we think a lot about, design in terms of like, how our kitchen works, right? You want a kitchen where you don't bump into each other and things don't, doors don't hit on other things. And so when we redo a kitchen, right, you can imagine we would just walk in and say, yeah, put the island over there about 3 feet across from the stove, and put the pantry and then put the refrigerator next to it, right? You can imagine just going and writing that down. And then you're going to get a kitchen where stuff like this happens, right? Where the cabinet door hits the sprinkler and the doors run into each other, like a horrible kitchen, right? If you want a kitchen that's going to work well, you have to do this, right? You have to have specified plans with measurements, right? Exactly the same for building programs that do the thing you want, right? Vibe coding can get you to a kitchen, right? It's not necessarily going to get you to a kitchen that works really well. So the reason that we use computers at all is we're not using them just because they're fun, right? Well, they are fun, but we're using them to solve problems for us, right? For us, our problems are mostly scientific problems. We have a bunch of data and we want to get an answer to a question from those data. Programming is the art of, and science, I guess, of specifying that problem precisely enough that a computer can solve it successfully. Often at least in the past, we've thought that isn't possible using human language, that you need some kind of more detailed language, and that's why we have programming languages. I think that's still largely the case, but increasingly, depending on the nature of the problem, a lot of problems can be solved simply by telling an AI system to do it simply using human language. But we're increasingly moving towards more abstract specifications that look more like natural language, at least for some problems. So the big point I want to make is, like, the most important part of programming or software engineering is not the generation of the code. It's understanding and decomposing the problem so that you can then go describe it to a computer to solve it. And what AI tools do is let us get from that problem description to working code much more quickly and often much more effectively. So I'm not going to say much about large language models, but this is the basis for the tools that we use. And these are models that are just trained on a huge amount of text to predict the next thing, but they can magically do all sorts of other stuff, having ingested a bunch of code and a bunch of other text. There's one important thing about large language models that I think is really useful for thinking about interacting with them as coding agents. So large language models do this thing we call in-context learning. So these models are big neural networks. They've been trained on a ton of text, but when you go in and you start talking to ChatGPT, the model isn't actually changing in the sense, when a neural network learns, it learns by changing its weights. But when you're talking to ChatGPT, it's not changing its weights. All it's doing is building up a representation of everything you have said to it. And then when it goes to generate the next thing, like the answer to your question, it's using all the stuff that it's been trained on and then sort of conditioning that on the contents of the stuff that you've typed in, right? So it kind of puts all that together. So what this means is that, anything you need the model to know needs to be specified before you start trying to tell it what to do. And I'll show you some examples of kind of how to think about that. Early on in AI, that's been, now people have sort of reconceptualized that as what we call context engineering. The idea is, let's figure out what needs to be in the model's working memory, if you will, so that it can go solve the problem effectively. Again, I'll show you examples. So I think there's an argument to be made that coding is maybe the optimal use case for large language models. And the models don't hallucinate anywhere near as much as they used to, but this is such a great hallucination that I have to show it. This is from GPT 3.5. GPT 4 sometimes did the same thing, but if you go in and say, who is Wayne Poldrack? Wayne Poldrack is my dad. He's a retired accountant who lives in Rosenberg, Texas, small town. GPT-3 would say, Wayne Poldrack is a prominent neuroscientist who's known for his work in the field of cognitive neuroscience. He's currently a professor at UT Austin, where he's director of the Imaging Research Center. Wayne Poldrack was never a neuroscientist. He was just an accountant. What awards has Wayne Poldrack won? It tells you a bunch of awards he has won. A few of those I've won. Most of them I've not won. Some of them I don't think exist. So it comes up with all sorts of stuff. But this is the kicker. My grad student Lindy tried this. Says, is Russell Poldrack a different person? I think you may have meant to ask about Russell Poldrack rather than the misspelling. Russell Poldrack is actually the same person as Wayne Poldrack. Russell is his middle name, and he often goes by Wayne rather than Russell. Russell's not my dad's middle name. To clarify, Wayne Poldrack and Russell Poldrack are the same person. Pretty hilarious. So obviously we can't just trust what the models tell us, even though they've gotten better. But coding is a case. So models like these are really good in context where the output is kind of hard to make, but easy to check. Chris Gorlewski has a blog post talking about this. And so the idea is we can use the models to generate code. Code is relatively easy to test. Now, it sometimes takes work to build the right tests, and we'll talk about that. But it's straightforward, and actually the LLMs can build a lot of the tests for you, as we'll see. Okay, so I want to do another poll. Just want to get a feel for what the level of experience is in the room. So if you can go on again to pollab.com/Russ Poldrack and for whichever of these that you've done, using chat interfaces, code completion, coding agents, or if you've never used any of them, go ahead and answer. And once we've gotten a few answers, we can. Okay, so I'm getting the feeling that a lot of people here have some experience using the chat interfaces like ChatGPT, and as I expected, not very many with agents, but most people have tried something. Okay, this is great. So I'm going to talk about all of these different things, starting with the chatbots. So if you go to ChatGPT and ask it to generate some code for you, it will generate code. I generally don't use this interface. Just because I think it's not optimal, because it doesn't interact, it doesn't like, it's not built into the rest of your kind of like development workflow. I will often use the chatbots for code review. And I'll show you an example later of using Gemini, the latest Gemini Pro 2.5, which I think is the best for like academic. I don't use it for like code generation generally, but for anything academic, for code review, reviewing papers or anything like that. My feeling is that Gemini right now is the best of the frontier models at doing that stuff. And it's really good at code review, as you'll see. Now, if you write code, you probably use an integrated development environment. If you're writing Python, most people are using either VS Code, which is free, or Cursor, which is a paid service that has a lot of AI integration. I started using Cursor, but I'm kind of back with Code now. And so VS Code has GitHub's Copilot, which is their kind of like, both a chat. It's like, this is what you see if you go there. You see a chat window where you can go back and forth with the model. And then it also, if you're just typing code, it will do auto completion for you. And this is by far the best way to do it. So one of the things you get here, if you're at the chat window in ChatGPT, it's not going to know about all the other stuff in your project. If you're at the chat window here and you want to say, well, I've already written some code and now I want you to generate some more code, you can put that other code into its context by just basically saying, add context, add in a file, and it'll know about what's in that other file and it can read it and then sort of work around it. So I think for most people, this is the optimal way to do AI assisted coding. Now, in the last year or so, we've seen the advent of what are called coding agents. And these are basically large language models that have access to other tools, either tools on your operating system, or it could be talking with other language models. Sometimes you'll have multiple language models talking to one another. And I'm going to show you some examples of Claude Code. Claude Code is something you have to pay for to use. If you have you can get a Claude, forget what is it called, Claude Pro, I think, which is like $20 a month, and you get some degree of access to Claude. But if you're trying to do a big project, it might basically say, sorry, you're out of tokens for today. You might have to come back tomorrow, unless you want to pay more. I find the agents are really good, especially so there are agents both that are built into, like, there's an agent mode that's built into here where it can go generate whole new files and, do things. Claude Code just runs in the command line. And it's really good. I'll show some examples of it, but it's especially good for like project level things. Like if you want to develop a whole new package, Claude Code is the way to do that. If you have a MATLAB package that you want to convert to Python, Claude Code is a way to do that, because it can often go off on it and work by itself for an hour sometimes, if it gets into a role and is like, you've given it permission to do all the stuff. So I started playing with this stuff back in 2023, right when GPT-4 came out. We put out a preprint that did some early analyses of the ability of GPT-4 to do code generation. But the speed with which the models are advancing is insane. To the degree that like anything I say today is almost certainly going to be outdated in 6 months. I kind of totally revamped the talk in the last month because I realized the things I said last year were mostly totally outdated. But this is, so one of the ways that there's various ways to quantify kind of the power of models. I like this. This is an interesting way to frame it, is basically, what is the, like how, it's called task duration. The idea is like, what is the duration of a human problem that the models can do with some degree of success? So this is basically telling you what's the task duration where the AI has an 80% chance of succeeding, right? And so this is basically saying back when we started looking at GPT-4, it had an 80% chance of succeeding on problems that would take a human about 2 minutes to solve. The latest models like O3 can now have an 80% chance of solving a problem that would take an expert human about 20 minutes. And you can see that they're actually, this is an exponential function fit to the data. I mean, these things are going up super exponentially. Yeah, JB.
But you have an idea of what kind of task, the variation of tasks, because when you said tasks that last for 20 minutes, I can think of like very, very different kind of tasks.
Yeah.
That's going to impact or not.
Yeah. There are, I mean, I don't know the breadth. So like there are these benchmarks like SweDench and stuff like that have problems that are hard where these models, fail pretty often. And that are meant to be basically to be able to kind of, show their success, like problems where, probably like, if you were a professional software engineer, you would be expected to solve them, but, in some number of hours or something like that, or minutes. But I don't know the breadth of them. I think they're meant to be, pretty broad. And these models are incredibly good at solving things that are common out. Like if you ask it to go like do some kind of like simple text processing or something, they're always going to get that right. For hard things, obviously it's, they're much less likely to get it. But yeah, I don't know the full breadth of these things. This is that same analysis, which basically showed that the length of tasks that AI can do is doubling depending on the analysis, either every 6 months. They have another analysis that suggests it's probably doubling more like every 3 months right now. So again, things are moving insanely quickly. So in 2023, I started by just developing a bunch of kind of data science-y problems by hand. So I gave it 32 coding problems to solve various. I'll show you some examples to solve various problems. And it succeeded where success basically meant it gave me the answer that I was expecting. So it's kind of a qualitative analysis. And I gave it some number of prompts to success. So about a third of the time it got it on the first try with no additional prompting. Another third of the time it took me a little more prompting. And then about a quarter of the time I basically gave up after a few minutes of effort. Because it wasn't solving the problem and it wasn't clear what needed to be done to solve the problem. I redid this with Claude Code a couple weeks ago, all those same problems. This is using Opus is Claude's like huge model. Sonnet is its smaller model. And what it does is it starts using Opus and then you run out of Opus tokens. And so it flips over to Sonnet. It got 29 out of the 32 problems solved. On 19, so on more than half of them, it succeeded with no additional prompting. And then the remainder, I had to give it a couple of additional prompts to get it to get the answer right. Because it hadn't done exactly, these prompts were not great prompts. They were very sketchy prompts. And so it misinterpreted what I wanted. It also wrote tests for all the problems because I had given it in my instructions telling it to use what we call test-driven development. I mentioned that in my talk yesterday. A lot of tests didn't work, but they didn't work for like reasons related to the test package itself. The remaining 3 problems had runnable code, but they weren't giving the correct answer, and it wasn't immediately clear to me. I tried a few prompts to get it to work, and it just wasn't clear why it wasn't working, and so I gave up. But it's a real advance in terms of its ability to solve the problems. So here's an example of one of the problems. Create a simulation in Python to generate some synthetic data
fit 3 models to the data of different orders, compute the error for each model for the training data and the test data, and then plot the fitted lines for each of the models overlaid on the training data. And when I had GPT-4 do this a couple years ago, it gave me like, perfectly fine looking code, Python code. And it got it in the first try. I had Claude do it, and the code is kind of folded here. These are each different functions that it generated because I asked it to write code that's modular and well structured. So instead of just giving me one long script, it actually gave me functions and then gave me a main function down here to kind of do all things. If you're not a Python person, this won't mean much. But the point is that it wrote code that's better organized. It's not clear if that's because it's a different prompt that I gave to Claude than I had given to GPT-4. GPT-4 may have done the same thing. But it did both things. And then here's the output. And you can see that if you look closely, you see actually the data points are exactly the same. And that's because it used the same random seed. Does anybody know what the random seed that it used was? 42, which is that Hitchhiker's Guide to the Galaxy that 42 comes from, right? So that's its favorite random seed. And so it basically solved, this is what I was looking for, it solved the problem. Now, the models are really good at explaining what code is meant to do as well. So I hadn't written anything about what the problem, like why I care about this particular piece of code, right? This is an example of a concept in data science machine learning. And I wanted it to tell me what concept is the simulation meant to exemplify? And it says, this is the GPT-4, old GPT-4. The simulation is meant to exemplify the concept of overfitting in the context of polynomial regression, which occurs when the model becomes too complex, performs well in the training data, but poorly on the test data, right? This is exactly what I wanted it to tell me. And so if you have a piece of code and you don't know what it's doing, you can give it to one of the models, and they're going to be pretty good at telling you what the code is trying to do in general. But success is not always as it seems. So this is a problem. I'm going to show you the GPT-4 output, and then we'll talk about how Claude did. So I said, again, this is a terrible prompt, right? Generate a Python class that fits hurdle regression model with a scikit-learn type interface. Again, if you don't know about what a scikit-learn type interface is, it's just a particular way of calling the functions, kind of a style of setting things up. Hurdle regression is a model. It's a statistical model that one uses when you have count data, like you're counting things, but you have a lot of zeros. They're called zero inflated count data. It basically combines a model for zero versus not zero and another model for the counts. And it told me what hurdle regression is. It kind of knew about it. And then it says, here's an implementation of it. But when I looked at the implementation, it wasn't doing it right. Like it was using linear regression when it's meant to be using like a count regression. So I said the continuous model should use a regression method. Fortunately, spelling doesn't seem to matter anymore. A regression method that is appropriate for counts. You're right. They always say you're right. They're kind of sycophantic, right? You never know if you're actually right or if they're just like kissing your ass. Yeah, you're right. Here's for count data. It actually ends up using the wrong Poisson model, but at least it gets closer. And then I had told it to generate, a test? Oh, right here I say, please use an example data set that includes zero in the outcome. So it was generating an example data set and testing on it. But the data set that it was using didn't have any zeros, so the model was failing because it expect to have some zeros. So apologies, sorry, I'll use a different data set. Okay, so it finally got something that was working, and I said, now please create R code to compare these results to an existing implementation of hurdle regression. So it knows that there's one in this package for R. It goes and finds it and puts together some code to run the same data through the R version and the Python version. And initially they were way off, right? This is you just look at the mean squared error, how well the model fits. This is how well the Python model fit. This is how well the R model fit. And just something was like way off there, right? And I had to go in and figure out, it wasn't really helpful in figuring out what was going on. I had to go figure out what's going on. I'll come back to that. And so I did some more human debugging, And I got it pretty close, right? The output, now the mean squared error is 5.19 versus 5.04. Clearly not exactly the same, but in the same ballpark. So I kind of moved on. But then I looked at the actual code, and I saw that it was fitting the model in a way that is not the way that this model is supposed to be fit. So the way the model is supposed to be fit is you have those two models. You have the count model and the kind of binary 1 versus 0 model, and you combine them. You do like maximum likelihood estimation, and you combine the two likelihoods. What it was doing is fitting the two models separately and then combining their predictions, which sometimes will get you close, sometimes it's going to be far off depending on the data. If you go look at GitHub at all of the hurdle regression implementations I could find, they all do it the wrong way. So basically, it was just inheriting the stupidity of the crowd. You know, everybody who'd implemented it before had done it the wrong way, so it thinks that's the right way to do it. So what about Claude? Can Claude get it right? Well, okay, so let me, and again, small text, but I'll kind of like, this is the kind of the transcript of my session going back and forth with Claude, where it says user, that's me talking. If it says assistant, that's Claude talking. So I say, I've added, so the way that you often do this with Claude, there's a file called claude.md, like a markdown text file. And you go in there, and I'll show you an example later, but you put in all the stuff you want it to do, a description of the problem, any of your preferences about how code is developed. So I said, I've added a description of the package requirements to Claude MD along with my development preferences. Please generate the package based on these requirements. So it goes in and says, okay, perfect, I'll implement it. And then I've left out a bunch of stuff here. At some point it comes back, perfect, I've successfully implemented the hurdle regression package. It tells me about all the stuff that it did. 15 tests, all passed successfully, confirming the implementation meets the requirements. The package is ready to be used. Well, I looked and it used the same incorrect method that GPT-4 had used. So I say, the implementation uses an incorrect method for the hurdle regression model rather than separately performing the two regressions, blah, blah, blah. See the attached PDF for a more detailed description, and I give it a PDF file that describes the model. It says, okay, I'll read the assistant says, Claude says, I'll read the PDF to understand the correct hurdle regression implementation and update the code. Okay, now I understand the correct approach. The hurdle model should use joint likelihood optimization. Let me rewrite the implementation. And it does a bunch of work. I'm leaving out a bunch of input, a bunch of outputs, a bunch of like stuff that's on the screen. Perfect. I've successfully implemented the hurdle regression implementation using the correct approach. Here's a summary of the key changes made, and it tells us about what are the things that it did. Okay, so now I say, please implement a test that compares the parameters estimated by this function with those estimated using the hurdle method implemented in this R package. I said, okay, I'll create a test that does that. And it has trouble getting R. It has to try like several different ways to get R working, but it finally gets R within Claude. It finally gets R working within Claude without me doing anything. It says, great, the test is working, showing our coefficients match R's exactly. The issue I have is that the sign convention is wrong for the zero logistic model. So if you look at the count coefficients come out perfectly, the zero coefficients, they're the same magnitude, but opposite sign. I don't know why it's. Oh right, so I think right. These should be positive. But the log likelihood match is the same. So, and it says the issue is that R's package models the probability of zeros, while our implementation models the probability of non-zeros. That's the problem that I had to figure out on my own that caused those numbers to be so far off, is it was predicting zeros rather than non-zeros. It figured it out on its own and fixed it. It took it a few minutes, and but it got it. And so now, okay, excellent. I've implemented the package. And and everything runs, all the tests run, the parameters come out exactly as they should, and so it works. So Claude finally got it. It just took me several kind of things going back and forth. It took me actually looking at the code to know whether it was doing it the right way. Let me stop and see if there's any questions before I go on.
How do you compare this with your PhD student?
How do I compare this with my PhD students? That is unfair. One of my PhD students is on Zoom right now. I think that, Claude obviously can do a lot more than any human can in a particular amount of time in terms of code generation. Neither I or my PhD students or most professional software engineers are going to be able to generate code at the speed that Claude does. But Claude doesn't have the ability to deeply understand the things that are kind of like I showed, where it's using this, it has a fundamental misinterpretation of how the model works that you would only know about if you deeply understood the model. Now, maybe if I had given it the paper up front, it would have better understood the model, but it started with what it found with what it knows from its training data, which mostly comes from GitHub. And so I think that's the difference is that, humans still have this ability to kind of think more deeply about, in a critical way about the problems. Yeah.
I mainly use Gemini. When I do write a good pipeline, I usually do start the meeting on Gemini. We go over it step by step, and then implement it. Can you do something like that in cloud, or is it just only cloud generation?
No, you can. So the question is, can you, often what you might want to do is tell Claude is have your agent. So we heard about Gemini, right? Being able to do this. You can give your agent, basically tell it what you want to do and have it plan out how it's going to solve the problem, go back and forth about how it's going to solve the problem, and then have it generate code. That's what you're getting at, right? You can tell Claude to do that too. You can basically say, don't generate any code yet. Let's think through a plan for how we're going to solve. Tell me how you're going to solve the problem. But don't generate, you just tell it, don't generate any code yet. And then it will think through it, and then you can do that. Yeah. Okay. So let's talk about a failure. In general, I think math is still something that's fairly challenging for these models. This is a problem that I did with GPT-4. So there's a model called the easy diffusion model. So diffusion models are models we use to model reaction times. And easy diffusion model is a model, it's like a closed form model where you just take the mean and variance of response times and a few other numbers, and you plug them in and you get back these estimates without having to do any sort of optimization. And this is from the Wagmacher's paper. This is the equation that describes one of those things, which is called the drift rate. So I say generate Python. This is from my early analyses. Generate Python code to simulate a drift diffusion model. Simulate 1,000 trials from this model. Estimate the drift rate, boundary separation, starting point using the easy diffusion models. Okay, so it tells me a little bit, and then it generates some Python code that says it's going to do that. But it clearly didn't understand the easy diffusion model. The easy diffusion model is just a set of equations where you just plug numbers in. But it tried to do like a optimization problem on this easy diffusion loss, which it clearly just didn't understand how the easy diffusion model works, and it gave you numbers that didn't make sense. And so I say, okay, now the easy diffusion model uses closed form estimates, doesn't require optimization. Apologies for the confusion. You are correct. And here's some corrected code. But it didn't do it correctly. It did something that looks correct. It uses the correct variable names, V and A and Z. And what's cool is that, / interesting, is it gets it almost kind of in the ballpark. So this is the correct equation over here. This is the equation. If you take its code and turn it back into an equation, this is what it looks like. So it knows that, there's some stuff up here with PCs, and that VRT is down on the bottom, and it knows that something is to the power of 1/4. So clearly it kind of found something that told it a little bit, but it clearly did not get it right. So one question is whether you could do, multimodal, use the multimodal models to try to give it a picture of the equation and see if it could figure it out. So if you first just say, tell me the equation, it clearly gets, this is a different version that it gives you that is not correct. I say that's incorrect. Do you have access to the original paper? Sorry, I can't. It doesn't have access to the original paper, so it can't pull it out. And so it wasn't able to get it. And if I did this last year, 2024. I tried when I initially did my analyses, it didn't have multimodal support, so you couldn't give it images. Then later they gave it the ability to ingest images. So I say, here's an image of the equation from the paper. Can you please, turn this into math? And here it does a little bit better, but it still doesn't get it correct. In this month, I tried again. I gave it that, and this time instead of telling it to turn into math, I just turn it into LaTeX. LaTeX is this language for writing down equations, right? And so I said, please convert the attached image to LaTeX math code. Here's the code, and it actually gets it right. So it, now it suddenly can properly turn. Actually, no, interesting. I just realized it's missing this. So it gets everything right except for that missing S right there. I hadn't noticed that until now. And maybe that's why Claude didn't. Oh, interesting. That's probably why Claude didn't get it right. That's part of why Claude didn't get it right. So Claude mostly got it right on the first try, but it gave me stuff that ran, but it wasn't, it was doing these parameter estimation things where it would generate data with known answers and then see whether the estimated values come out close to the true values. And they were way off, right? Boundary separation should have been 1, it was 0.2. Starting point should have been 0.5, it was 0.1. And I gave it that slightly incorrect. Actually, no. So it was a different. It was a different equation. Another of the equations it was getting really wrong, and I gave it a LaTeX version of that one, and it still failed the test. So. But it basically gave me mostly working code. What needed to happen that I didn't have time to do was to go through and exactly compare all of the equations that it had in the code to the equations in the paper. And I'm sure that, I know that a couple of those are probably wrong. And if they were to be fixed, then it should give us the right answer. So it got 90-something% of the way to the answer. Just took a little bit of extra human work to get there. So I think that, I mentioned that one of the nice things about code is you can test it. You can make sure that it's doing the right thing. And so if you're going to be using AI generated code, you really need good tests. And AI tools can generate the test for you, but you need to make sure the tests are correct. And that can be a little tricky. So here's an example, again, going back to the 2023 work. One of the problems we gave it was, this was a second set of tests we did. Write a Python program to determine the escape velocity from a celestial body given its mass and radius. And then this is a bunch of boilerplate. And then at the end, generate a set of PyTest tests that exercise each of the functions embedded in a separate code block. Okay. So it creates a function called escape velocity, and it creates a test for that function. And this is what the testing situation looks like. We say, it's testing for Jupiter, right? So we know the mass of Jupiter, we know the radius of Jupiter. We get the result from that escape velocity function, and we're going to assert that that result is approximately the same as this known value, right? 59564. But the code comes out with 60202. So now the question is the code wrong? Is the test wrong? What's wrong? Why is it failing? And this took a bit of time to figure out. I'm not a planetary scientist, so I had to learn a little bit about planets. Planets, it turns out, are prolate. They're kind of oval, right, because of spinning, right? And so it turns out that the escape velocity depends on where you are on the planet. And there's two different ways that people commonly compute the radius of a planet. One is the equatorial radius, right? How long it is around the equator. The other is the volumetric mean radius, which is the average radius from all the points, which is, somewhere above the equator. And both the code and the code is correct. The tests are correct depending on, but they basically are mixing together two different places on the planet. So the escape velocity that NASA's Jupiter fact sheet states, which is the one that they're using, is for the equatorial radius, but the value generated for the code was computed using the volumetric mean radius. So you have to make sure that all the different numbers kind of go together when you're building the test. So you need some domain knowledge to really know, what's right there. So, I talked a bit yesterday about code review. I think code review is essential both for learning to be a better coder and for improving the quality of your code. And one of the things we often do when we do code review is something called refactoring. Refactoring is the idea of like changing your code without changing its function, without changing the output, right? So the idea is we're going to change the structure of the code to make it more readable, more maintainable, more robust. Even though it gives you the same answer in the end. And having tests to make sure that it gives you the same answer helps you do that refactoring. It turns out that LLMs are really good at this kind of like both reviewing and refactoring. So here I'm going to use Gemini. I have an example that I had generated a while ago of like really bad Python code. It's kind of fun to sit down and try to write horribly structured code. And so I did this for an example. I gave it to Gemini and said, please review the following Python code. And 1, identify the intended goal of the code. And 2, identify any anti-patterns that are present in the code. And the goal was not like the variable names in general do not really specify what the thing's trying to do. So it tells me the intended goal, which it gets right, loads, basically to perform an exploratory factor analysis on a data set of survey responses and see how those constructs relate to a measure of mental health. And it kind of pulls out all the things that the code does, which is not, if you're, it's kind of spaghetti code with terrible variable names and, not written well at all. Okay, so then I ask it to look for what we call anti-patterns. An anti-pattern is basically a commonly used but bad solution to a common problem. And so if you go search for Python anti-patterns, there's a whole great website that walks through like all the ways that you can write bad Python code. So it finds a number of these. Code contains several anti-patterns that make it difficult to read, maintain, and debug, like wildcard imports from pandas import star. Terrible because it makes it impossible to know where functions are coming from when you use them. Non-descriptive variable names, uninformative names like H, C, H, SC, GS, blah, blah, blah. So better practice is to use descriptive names. Inefficient looping rather than vectorized operations. So instead of using Pandas's operation, for example, to drop NA values, you can just, it was like looping through things, which is a lot slower. Lack of functions in code organization. The entire script is written in a single linear block of code. So it'd be better to break it into different functions. And so I had embedded intentionally embedded an incorrect computation of a particular statistic, a Bayesian information criterion. I just kind of made up a way to compute it that was not correct. And I don't think any human has ever looked at it and figured that out, but it basically says the formula used to calculate the BIC-like value is not the standard formula for BIC. This could lead to an incorrect choice for the optimal number of factors. So it's actually finding not just kind of code errors, but it's finding, numerical errors. And it also says, oh, you're redundantly fitting the model. You should be saving the results from each model. So it finds a lot of the issues in the code that I had, intentionally put in there. So it really good, both to make sure that nothing's wrong in your code, but also to learn how to write better code, assuming that that's something that you want to do. And I think it is, because when you go back to look at your code next year, basically you're going to have to figure out what it was doing. And if obviously you can just ask the model next year, and the model next year will be 100 times better than the model today. So it'll be able to tell you, but, so I want to end by just talking about, given that increasingly we're using not just, LLMs as kind of like autocomplete, or really LLMs as coding agents. And Anthropic has a really nice sort of piece about sort of best practices for how to optimally use agents like Claude Code. And so the first thing is really just going back to what I said earlier, make sure that it has everything it needs to know. So if you're using Claude, you would put it into this Claude file So you want to have commands like, how is it going to build the project? Is it going to use a particular system to like code management system? Like I use UV to manage all my packages. If there any sort of code style stuff, if you want to write in a modular and readable way, if you have a particular, there's various different workflows for writing code, and they lay out a number of those. One that I like is what we call the test-driven development workflow, where you basically write the tests first, commit those tests, then write the code to pass the test and commit. And it's really important to tell it, don't change the test to pass just so that they'll pass, because they will do that if you don't tell them otherwise. And another way to think about this, so these models are the agent systems are really good at kind of like working on their own if they have access to the right ways to get feedback. And so you have to think about how can you allow the model to get as much feedback as it can on its own. So here's, for example, this is over the last few months, I've developed like the things that I like to tell Claude to do when I go build a package. So I have a section in my Claude file called development preferences. One is think about the problem before generating code, right? Going back to what you had said earlier. Use a test-driven development strategy, developing tests prior to generating solutions. Run the tests, ensure that they fail, then write code to pass the test. Important, do not modify the test simply so that the code passes. Only modify the test if you identify a specific error in the test. Always add a smoke test for the main function. The project is managed by UV. Prefer reliance on widely used packages rather than unknown packages from GitHub. Because sometimes they will see that there's a package in GitHub named something like what you're trying to do, and they'll go grab it. And there's actually examples of people who've used this as a vector for security attacks, where they'll put up a package on GitHub that basically just has some kind of compromising code in it, knowing that LLMs are going to try to pull the package down and run it. I personally hate when there's code in the init.py file because I feel like it's unseen and it makes it hard to debug. So I tell it, don't do that. Use PyTest for testing. Write code that's clean and modular. Prefer shorter functions methods over long ones. Create code that will work on Python 3.12 or later. If you want it to work on older Python, you should tell it that. But asking the model to think is really helpful, and watching it think is pretty fascinating. So I had one of the problems that it failed on in that initially with Claude was Python code to read an image and then render that image using ASCII art, where you use characters to kind of render the grayscale image. So I gave it this image of the evolution of code, and this was the initial output. Clearly, it is not doing it correctly. It's just giving me basically almost all the same characters. So I tell it the code for ASCII art 28 runs, but the output doesn't seem to be correct. Most of the images are composed only of the ampersand. Can you think of a strategy to ensure that the output is correct? So it starts thinking, it gives you the little thinking tag and says, let me think about this. Common issues. What are some common issues? And it lays out several common issues that can happen. And then this is all it talking to itself. Well, this is not me saying anything, right? A good strategy would be to do these things. So let me start by examining the current implementation. And then it says, you're right to be concerned about that issue. It usually indicates an issue with the grayscale to character mapping. Let me examine the code and develop a strategy. Again, this is all the model talking, thinking. Great, I found the problem. The test shows that the mapping is only producing that character. So it's developed a test now to find the problem. So now it knows if in order to solve the problem, it needs to first pass that test. So it says it might be an issue with the calculation. There's a couple of problems. Let me run a focus test. So it goes out, it knows because it's an agent, it can go out into the operating system and actually do stuff. So it goes and runs the tests and thinks of it more interesting. The character mapping calculation looks correct. It should produce this range of 0 to 255, but when I tested it, only produced those characters. So let me check what's actually happening. Let me debug further. Thinking, that's strange. The resize is working correctly and the pixel values look good, but the ASCII conversion is still producing only ampersands. Let me check what's happening. Oh, now I see the problem. The character mapping is working, but the issue is that all the low pixel values are mapping to 0. The gradient image is being heavily resized and most of the pixel values are falling into the lower range. Let me see how to fix that. Oh, there's thinking, there's definitely an overflow issue. Let me investigate this overflow issue more carefully. Found it. So this was probably 15 minutes worth of it, like trying a bunch of stuff. The issue is with this particular thing in NumPy. Solution is to convert the pixels to a larger integer type. Let me fix this. Okay, excellent. The fix worked perfectly. Now the art is using all 10 characters from the character set and creating a proper gradient. Let me test it with a sample image to see if it produces better results. Perfect, it's now working. And it actually was working. So that was, like I said, a lot of back and forth, but mostly it was it talking to itself. Like I just got it started basically saying, hey, there's a problem. It did all that work on its own. So it just shows you how, how increasingly powerful these tools are at solving sort of bigger and bigger problems, and really highlights the need to get your head around how to use these. Because if you're not using them, you're really depriving yourself of, of some amazing resources. So another last thing to talk about is just like the need to be as specific as possible. So these are examples from the Anthropic best practices, and they have this great quote: Claude can infer intent, but it can't read minds. And they should have in parentheses yet, probably. But this just shows how, like, instead of like my initial prompts were more like these on the left. They're just like telling it way too little. Over time, you learn to move towards much more detailed prompts that kind of lay out exactly, what you want. And there's also all these interesting workflows where you can have different versions of Claude talking to each other. So really starting to have, like, one agent write the code, another agent kind of do the testing, so that the code writing agent can't cheat by tweaking the tests. So finally, I think I mentioned this yesterday, but I have this new book I'm writing, like living textbook online, about using AI-assisted coding. And I release sections weekly or daily this week on my Substack. So follow that. Right now the content's coming out is all about testing, so that'll be, I think, useful for you. But we'll dig more deeply into AI workflows in the future. And the fact that it's an online textbook means that we can change things, so it'll only be 6 months out of date, not years out of date. Okay, so if you're writing code, you should be using AI tools, but you still need to understand the principles of software engineering and programming, how to decompose problems, how to express problems in as detailed a way as can. And I think, don't offload all the work to AI. So, vibe coding might be fun, but I think it's not a great way to do science. You can use AI to help you do a better job, but ultimately you need to understand what the code is doing, so that you can have faith in the answers that you get out of it. Thanks.
I think we maybe have time for one quick question.
I'm curious how you think about authorship with AI, and like, as an example, I'm trying to write something right now that I want to publish for use, and AI has been heavily involved, like the back and forth. And at a certain point, if it's writing the majority of the code and generating it, is it like, how do you think about, can I put my name on that, or do I include GPT in that?
What we generally do, like if I have a package that I put up on GitHub recently that was totally written by Claude Code, and I said, it's copyright me, right? I'm licensing it, it's copyright me, but I said this code was generated by Claude Code. So I think just being clear about what role the AI systems play, because ultimately it's you who's driving the machine to do the generation. You're giving it the problem. And there's all these like interesting questions about like whether the AI system should be listed as authors. I think that the current understanding of most journals is now that AI systems are not to be listed as authors, but that you should have a disclosure of the role that they played.
All right, I think we're kind of at the time here, but I encourage everyone to go to the Poldrack AI channel if you want to talk about this a little more. This is a big topic, and we're probably going to be using AI in the rest of the course and stuff. So let's talk about it. Right now, we're going to take a 30-minute break. There should be coffee out there. And we'll be back in a half an hour for the Python lectures. Just a quick reminder that we're not in Alder 107 because it's locked. Instead, we're going to be in Alder 106 if you're going to the design and implementation of libraries. Other